So if we had been in class, we would have done this investigation in which we would have drawn a circle using a compass and then drawn a chord going across that circle. And then we would have folded this down the middle so that this side of the chord is folded perfectly on top of this side of the chord. And then we would have unfolded the paper and made some guesses about what is true of this line right here. And I think maybe you can just tell from the way that it's drawn some things that we observed, that it does appear to be a 90-degree angle. So the fold is perpendicular to the chord. It appears to cut the chord in half, and in fact we know that it would be cutting the chord in half because we would have folded it on itself. So the fold cuts chord in half. In other words, it bisects the chord. And then a third thing you may or may not have observed was that it appears to cut this arc in half as well. That is, it bisects the arc, the corresponding arc. And there's still one more thing that is really neat about this fold and about where it's located. This yellow fold that goes all the way through the circle, it doesn't go just anywhere through the circle, it has to go through the middle. The chord, the fold, is the diameter of the circle. So there were really, I guess, 4 things we could have observed about that fold. All right, so our theorem says in a circle, if a diameter or radius is perpendicular, if it makes a 90-degree angle with a chord, then it bisects the chord and its arc. That's a lot. That's a lot. So we're saying if you have a line segment that goes through the middle, doesn't matter if it's a radius or if it goes all the way across the circle and is a diameter. If there's a box here, then it's going to automatically have ticks here and here, or vice versa. If there's ticks, there's going to automatically be a box. Okay, so here we go in example 2. A lot going on here. It says HI is congruent to JK. So let's look at what we've got. We've got 2 chords that are congruent. We already had a theorem today that said if those 2 chords are congruent, then the part of the circle that those 2 chords cut off have to be the same. So the yellow chords are the same, the green arcs are the same, length and degrees. The other thing I'm observing here is I have a radius that's perpendicular to this yellow chord, and I have a radius that's perpendicular to this yellow chord. And so our last theorem said if the radius or diameter has a box, then you automatically have ticks, and you automatically have ticks on the chord too. All right, so let's look. So other stuff. HQ, it tells us is 48 degrees. I think that's degrees. And then it tells us JR is 7.5. So now they want to know how much the whole arc HI is, and pay attention to the symbol. I know it's an arc and not a chord length because it's got kind of the rainbow look to it and it's not straight across. So, but from here all the way to here would be 48 plus 48 or 96. Then for QI, well, it had to be 48 because it was bisecting. The radius was bisecting that arc. From J to K, so pay attention. Again, we're looking at the arc, not the segment. We know that these green pieces are the same as these green pieces over here. So this is also 96 degrees. And then HI, okay, this one doesn't have a bar on top of it. And when you don't have a bar, what this means is it's the distance from H to I. And so it's another way of saying what is the length of HI. So our only clue that we have is over here on this yellow chord, half of the chord is 7.5. So we know half of a chord over here would be 7.5. So 7.5 times 2, the whole chord would be 15. All right, so very similar problem down here. I hope you'll pause the video, give it your best effort, and then we'll come back and check and see how you did. Okay, so because the yellow chords were congruent, that meant the green arcs were congruent. They were cutting off equal parts of the circle. Then we knew because this green one over here was 70 degrees, this would be 70 degrees as well. And they also told us the yellow arc over here was 22 long, so this one over here would have to be 22 long. And all of this, all the matchy-matchy parts, all are congruent because of this statement right here, that the chords are congruent themselves. So RT was just half of the arc, so it was half of the 70, which was 35. VW, again, pay attention, it's the arc because it's got the swoopy thing over it, not the line. Again, 70. RS, now this time look, it's a line bar on top, so they mean the length of the chord, which would be 22, and for the last one, RK, again, length of half a chord would be 11.